Welcome viewers to the online series of lectures for the course of Algebraic Topology 1. In Algebraic Topology, one studies algebraic invariance. On topological spaces. One called them algebraic invariants since they are invariant under some sort of deformations called homeomorphisms. One studies topological spaces and the concept of homeomorphisms in points topology. It turns out that the knowledge of points topology is essential for studying algebraic topology. Since some of you may not have a background of points topology, we are dedicating our 0th lecture to the basic concepts of points topology. In the 0th lecture, we will refresh our memories on topological spaces, various topologies that we can put on topological spaces like subspace topology, quotient topology, product topology, and so on. We will also study continuous functions from one topological space to another topological space. We'll study homeomorphisms. We'll study the topological property of compactness, Hausdorff spaces, and so on. Okay, at this point, I want to say a few words about category theory in connection to algebraic topology. In fact, category theory first surfaced while studying algebraic topology. Okay, so we are familiar with the structures of group, ring, topological spaces, vector spaces, monoids, okay, and so on. These are all mathematical structures. Okay, sometimes we come across mathematical structures that are apparently distant from each other. But category theory is a very powerful language that establishes the interactions between all these known structures. Okay, and if we learn this language, we will be able to see how these already known structures talk to each other. One such example is the algebraic invariant that we were talking earlier, about. Such a functor, it is a functor. Okay, so I have to say what it means by a functor first. Okay, so a category consists of objects and morphisms. Okay, so there are objects in the category that talk to each other via morphisms. So this is one category, say category 1. There is another category here which has its own objects that talk to each other by means of its morphisms. Okay, now this category 1 can be related to this other category by means of a functor. Okay, it's like a function from one category to another category. Okay, so I just can say that it's a functor. It has to obey some rules as well, meaning that these functors should relate the objects here to the objects there. Similarly, this same functor should relate the morphisms here to the morphisms there in a consistent way. Okay. Okay. So roughly this is what's happening in category theory. So what we have told here, what we have mentioned here, these algebraic invariants are some sort of functors from the category of topological spaces to the category of groups. Okay, so when I'm saying the category of topological spaces, here the objects are the topological spaces and the morphisms are these homeomorphisms. And when I'm talking about this category of groups, there the objects are groups and the morphisms are group homomorphisms. Okay, so one such functor is the fundamental group. Okay, good. So all right, like I said before, that we need to have uh, enough background on point set topology to study algebraic topology. So our 0th lecture will be dedicated to point set topology.